Hello and welcome to my video on volumes of revolution. So I have here a past paper question from the OCR papers, and I should have a little thing up here for OCR to keep them happy. And yeah, so it's an unusual question because it's asking for a rotation around the y-axis, and normally in most of the OCR questions they ask for a rotation around the x-axis. And so in that sense, it's just a little bit different. I don't think there are any other questions around the y-axis. But anyway, let's move on. So it says we've got this curve here, and it's got the equation y equals 6 over root x minus 3. Okay. So let's scroll down a little bit. You don't need to look at the graph. Okay. So it says the point P, what we do have to guess, that point there, which we're integrating between that and the origin, has coordinates 0 and p, so we're not going to get a numerical answer. So the shaded region is bound by the curve and the line x equals 0. Okay, so it wants us to find the solid or volume V. Because we're going around the y-axis, we need to rearrange this equation. Okay, so the formula for the volume of revolution is pi, then you integrate between a and b, which is 0, and p in this case, y squared dx. And you may be asking why it's dx if you got y squared here. Well, we're simply saying is replacing the equation for y, so in this case that's this part here, and then integrating that between with respect to x. But when you're going around, that's for around the x-axis. When you go around the y-axis, we want it to become, well, that's right here, x squared dy. So we need to rearrange that. Okay, so if we rearrange that, we get y plus 3 equals 6 over root x. Okay, and then we need to square it to get that into just an x. You get y plus 3 squared equals 36 on x, and if you put the x over on this side and the y plus 3 squared on that side, you get x is equal to 36 over y plus 3 squared. Okay, so we've got that part now. We need to square the whole part before we can integrate it. Okay, so x squared is equal to 36 squared, which is 1296, on y plus 3 squared squared, which is y plus 3 to the power of 4. Okay, so now we need to integrate this part with respect to y. So let's write it down. We get pi integral, this needs to be a 0, it's our lower bound, and p, it says there, the coordinate is, y coordinate there is p, and we get 1296 on y plus 3 to the power of 4 dy. Okay, so you might find it a bit easier to integrate this equation if you write it in a slightly different way. So we can say that's equivalent to, 3 lines mean equivalent to, 1296 y plus 3 to the minus 4 dy. Okay. Now we need to integrate that. So we know that when we're integrating, we add a power to here. So if you add 1 to this, you get a minus 3. And if you remember, when you're differentiating, you're taking it down, so you're multiplying by the minus 3 here. So to integrate again, we've got to divide by that minus 3. So if I write this kind of integrating bit is equal to, I'll write pi, I'll use these square brackets, and then inside here will be the integrated part, and they have the limits, but you'll see that. So minus 3, we divide this by minus 3, because when you differentiate it again, it'll multiply through. So you got minus 432, which is 1296 divided by minus 3, and y plus 3 to the minus 3. And then the limits between between 0 and p. And I must point out too that you'd also have to divide, if that was 2y, you'd have to divide that by 2, because when you differentiate it, you'd be multiplying by the differential of this component as well. But since that differentiated just 1, we're not going to worry. Or at least I kind of skipped a step. Okay, so now we need to put these values in there. So we can say that's equal to pi, and we can take out the values. I could take out this 432, but we're going to find that it's actually, if we do that a bit later, it might be easier because of this minus 3 here. So minus 432 lots of p plus 3 to the minus 3. That's that bar, and then we need to subtract what this bit would be with 0 put into it. So the first part was with p, now into 0. So minus, and we've got another minus here. I'm going to put that in brackets so you can remember later that we need to multiply them together to make a plus. 432 lots of p plus, no, my bad. There we go. That's a 0, so that just becomes 3 to the minus 3. Yeah. And if we simplify this, we get pi. And let's just go back to regular brackets now. That becomes a plus. I'm going to bring that in front because it's nice to have the plus and then the minus part here. Okay, so 433, that becomes 27. And 433, because that's 1 over 27, divided by 27 is just 16. Okay, so that 3 cubed is 27. 1 over 27, multiply that by that is the same thing as dividing by 27, you just get 16. Right, minus 432 over, because we're taking this into account, p plus 3 cubed. So almost there. This is what they want here. 16 pi, or lots of 1 minus 27 over p plus 3 cubed. So if I scroll down a little bit, all we need to do now is factorize out the 16. So you've got 16 pi lots of 1 minus 27 on p plus 3 cubed. And that's the final answer. I think that's just about everything. Thank you for watching the video, and I hope to put up more soon.